However, I can have a coordinate transformation transfer from here to there or from there to there. Alright. That means AC hat can be AC and BC hat will be a transformation BC and C hat equal to C psi. And psi is a transformation. That means the eigenvalue of AC hat and eigenvalue of AC hat are identical. So that's what I explained to you in the system ID. I'm explaining the system ID. The system ID, I taught the system ID in the fall semesters. And then I'm teaching the control now in the spring semester. Okay, so to get a model, to get a system model, we can get from the theoretical approach, we can also get a model from system ID approach. That's what is going on there. All right. Now, because system always got some nonlinearity or system uncertainties involved there. So we always, the control guys or control engineers, and a lot of people use called adaptive control approach. That means we every once in a while, we need to update our model. We need to update our model. Understand about that? Because our model from physical coordinate may not be accurate enough because of nonlinearities, because of uncertainties. We need to update our model, and we need, after we update our model, we will design our model. Now, the predictive control. This is why I have a system ID here, because predictive control involves system ID. That's why I take time to explain the system ID here for you. Okay, so that's an online system ID, online controller design. Online means real time. Online real time means I let computer to do it for you. So my system ID, as long as I get data, input data and output data, my computer will recompute my model or update the model and so on for you. All right. Now, this is the second approach we call adaptive control approach. The predictive control is similar to adaptive control approach in here. The last one called autonomous control approach that combines systematic control design into one step. Now, I'm not talking about in this class here. All right. And there's a way to do that, but well, I'm not going to do that. But here in this class, we'll talk about online system ID and online control design and combine those two together. That's what we call predictive control. Okay? Any questions? But again, the system ID, let's say there are many books in system ID. I also wrote a book, system ID. Right? So there's many different techniques to do system ID. There are online system ID technique, there are offline system ID technique, there are all kind of technique going on. But they are all for linear systems. Nothing for nonlinear systems. Although I have a paper to talk about nonlinear system ID, but that's not in the book. All right, let us talk about the generalized predictive control. What do we mean generalized predictive control? Alright. This is some history of the GPC. The generalized predictive control we call GPC in short. GPC. So that introduced in 1987 by Professor Clark of Oxford University. And then that's input output sense. Also, they have some control index to do that for penalties. However, now we extended the last landing to cover some cases that we call unknown disturbance rejections. Now I will explain to you what we mean unknown disturbances. Like when it sit inside an airplane. Sit inside an airplane. We know that. They are very noisy. Because of what? All those noises come from where? From the outside air, right? From engines. Now, the engine, maybe we can say that's a non-disturbance. But aerodynamics, when you fly in such a high speed, the aerodynamics is difficult to say non-disturbances because aerodynamics, the wind, they are changing all the times. So we can classify them as unknown disturbances. All right, let's look at this. This is basic example. And this is a system. Now we have a census. And we go to computer. We have the force, total input force. And we have the output here. In this computer, we'll do system ID. We also do disturbance estimations. The disturbance estimation means because we don't know the disturbances, but we can estimate the disturbances based on our measurement. All right. Now, so far, we did not talk about system ID. But here, you got to be careful. So far, we learned two feedback methods. One is power placement, one is optimal control. The power placement and optimal control, we always assume we know AC, BC, and C, and D. Agree? We assume we know that. Well, in matter of fact, those methods, you can also use the ID model. We call AC head, BC head, and C head. That's still good too. You do not have to use the model from the physical coordinates. Instead, you can use the model from the ID. You know that we use U equal to F X hat. The X hat is our observer state. Agree? Our observer state. That's X hat. Now today, our feedback will look at this. Look like this. There's no X hat. There's no X hat involved in it. No X hat. What we have is our control will based on the past output and the past input signal. No state here, no X hat. We don't need X hat. We need the past output measurement. We need the past input measurement. That's another control method. Our UCK. We can look at this U equal to that UCK. But here we need observer. There we don't need observer. Okay. Now from this chart, which is simple. Which method you think is simple? Anybody tell me? It looks like this is simpler, right? Because pass y, pass measurement, pass u, the pass y and pass u, they're given. We know that. And we don't need the whole series of pass input and pass output. We need only up to k minus p. So we need only p steps of pass output and p step of pass input. Does that make sense to you? Now, this alpha 1c, alpha 2, alpha pc, beta 1c, beta 2, beta pc, those are the gain for the pass output and the pass input. So that c here means control. So alpha 1, control c, times y, k minus 1, beta 1, c sub c, uc, parenthesis, k minus 1, parenthesis, and this, the pass one step output, pass one step input, pass one step output times alpha 1c, beta, pass input step times beta 1c, and then we have up to alpha p super c times y, parenthesis k to minus p. That means the past p steps. And those information are available to you. So that's the gain. That's the gain. Those gain times not x hat. Those gain times the pass output and pass input. So the predictive control will teach you how to compute those. That's it. And that will involve systematic steps. Any questions? Think about it. Use your brain. It's good. As a matter of fact, this is, if you think carefully, this one really has its own embedded observer in it. And that observer really inside there. You just don't see it. But if you read the book will show you how they are related. Okay. Again, that's UC plus your command E, that's your total input force. All right. Now, I show you the differences between predictive control, optical control, and power placement technique. EU, the form of EU are different. So again, there are many, many different control methods you can use to control a system. And those, only 3 of them. As a matter of fact, I can add another one called ABA. ABA is one of them too. Okay, let us take 10 minutes break.